good today? Save yourselves for the party tonight. Good to see. Actually, I can't really see you at all. These lights are quite blinding. So that's me, Dave Fellows. I'm the lead architect at the GreenButton. A fun and demanding job. So what we're going to talk about today is a quick intro to the GreenButton, what it is. And the rest of the talk is really all demos, which is cool. And some of them are out to live Azure, so we'll hope all the demo gods and other cliches are working well. So I'm going to give you a demo of the GreenButton running in deep exploration. So we're sending a rendering job out to Azure and see what that can do for us. Did anyone see the demo yesterday in the foundation session? Okay, cool. Well, there'll be no surprises really. And then we're going to look at a few sort of lower level techniques and features in Azure that we've found very useful in the development of the GreenButton. So first up, we're going to be looking at the App Fabric Service Bus, and we're going to see how we can use this to communicate between with a loosely coupled communication between on and off premise applications. So pretty powerful. And then we're going to see how quickly use IntelliTrace to debug our services. Very useful. Before this was about, you could have a lot of challenges trying to deploy things and they won't really work out. Then we're going to look at the Windows Azure Drive, or the X Drive as it was previously known, and we're going to look at how this differs between the development simulation and in live Azure. And then we're going to look at how to use a lease on a blob message, a lease on a blob, and we're going to use this to maintain a lease on a queue message, which seems a bit weird, but I'll explain why that is useful later. Okay. So the GreenButton, what is it? Offloading complex processor-intensive work to the cloud. So things like for digital media, rendering, engineering design, sort of quite closely intercoupled with the digital media, so CAD models and photorealistic designs. And then for the biotech industry, we're doing DNA sequencing, protein analysis, testing out your latest drug. In the oil and gas industry, not so popular at the moment, but 3D seismic imaging for discovery and reservoir modeling. Then financial markets, Monte Carlo risk simulations. Really anywhere else where processor-intensive work is required. We're seeing the opportunities every day. And the key thing is this is a seamless interface for the user. All this massive cloud computing resource is available to them just at a click of a button. So pretty powerful. And at the moment, the GreenButton is a custom-built plugin for various different applications. We're in the process of developing an SDK, so anyone can pick it up and put in their applications to sort of enable this easy access to the cloud. So that's pretty cool. So the main event, let's see a demo of the GreenButton running inside deep exploration. So this application, Deep Exploration by Right Hemisphere, this is used by some of the largest manufacturing and design companies around the world, the likes of Chrysler, Boeing, Sikorsky, Nike, very impressive. And so I've created a simple 90-frame animation here of this Mustang. But if you want to see what deep exploration is really capable of, you want to visit whitehemisphere.com. And they've got some really, really impressive images where you wouldn't be able to distinguish them from a photo. Very cool. So we're going to set the rendering settings for this animation. So we'll just set a sort of a reasonable resolution we can fit in our projector. And then we're going to crank up the rendering quality to maximum. So we want the most photorealistic output from this thing. In this high dynamic range ray tracer, the quality settings define for each pixel how many light sources and environment samples are calculated. So very CPU intensive, which we'll see. So I'm going to render just a single frame on a local machine here, just so we can get an appreciation for what the scale of the problem is. So we'll see this image get pieced together, little square by little square. Pretty cool. And if we look at our CPU graph, you can see all 8 cores are getting an absolute thrashing, which is pretty cool to see. There's something about 8 CPU cores maxed out at 100%, which is sort of pretty captivating. Unless it's some rogue process like Norton or Java.exe or something like that. But in this case, it's pretty cool. So for the record, this frame is going to take around 2 minutes, 2.5 minutes to process. So you multiply that out for our 90 frame animation. We're looking at about 3.5, 4 hours to render this. So I'm not sure if they updated the program. I don't think they did, but this is actually running till lunchtime now to give us a chance to see this render out. I think, have they locked those doors yet? No. Cool. What's that? Use a green button. Ooh, that's a good idea. Okay, so we'll stop that then. Very good idea. Unfortunately, I've registered at greenbutton.net and have entered my login details in the plugin here. And so I can now submit this job out to Azure just by clicking the green button. And so what's happening here is the scene has been, all the environment maps, the textures and other assets associated with the scene are extracted out and cached on the server. And then we compress the job file as well to minimise the upload speed, the upload time. So it's hopefully, fingers crossed, yep, seems to be working. So it'll be saved up to blob storage. Cool, so the user can now carry on doing what they're doing with their computer without it being locked up or dedicated to rendering this job, which is pretty key. Now if we look over here, this little application we use to monitor and manage our back end, it's just a prototype application. The full version will be in Silverlight and look pretty cool. So we can see our job has appeared here with 91 tasks. It's actually a 91 frame animation. So, and if we click on that, it's pulling in all the frames. So we can see all of our frames have been processed at the same time. If you look over here, you can see the individual Azure instance IDs of each of the virtual machines. You also notice that we've got quad-core machines here. So we've actually got 360 odd cores cranking this job out. And you can see the slowly completing now. If we flick back to Deep Exploration and the plugin, you can see the user gets an up-to-date progress on how their job is going. So it's all good. Cool. So what we can also do with this tool is we can, for a particular instance, we can look inside the covers in Windows Azure and see everything that this particular instance is doing. So we can see it's executing the rendering application right now. It'll finish up soon. There we go, let's finish that. And so once they're all complete, the job, all the individual frame outputs will be gathered up and the job will be merged into the final animation, which it's doing now. This takes about 15 seconds and it'll be good. Cool, so if you flick back to Deep Exploration. Okay, so our job is complete. We can double click it and download the result. Overwrite that. The internet has behaved again, that's good. And if we bring up the let's have a look at what we created. Oh, time's a bit slow to load. Right, put that over there. And cool, so we have a 90 frame animation in what, a couple of minutes. So that's extremely powerful. You know, 3.5 to 4 hours on our desktop, locking it up the whole time. You know, in a couple of minutes in Windows Azure. Extremely powerful. Cool. All right, so that's the green button in Deep Exploration. Let's carry on. So we saw how we were easily able to break this rendering job up into individual frames and render those in parallel. So this sort of processing task you'd describe as being embarrassingly parallelizable, which it is. It's embarrassing. But certain other problems are more difficult to parallelize. So for a single frame image, for instance, which Deep Exploration is also used predominantly for, these very high resolution images for publications, and they can take 10, 12 hours to render just themselves. So for those, we can actually break them up into smaller chunks and distribute those across as well. So and also achieve the same thing, and then they're pieced back together again at the end. So this sort of pattern is a common pattern in the high-performance computing world called map-reduce. So the map refers to the processing on each subset of data. and it reduces the aggregation and merging of those results at the end. So the most effective way to perform this sort of work, parallel work on Azure, is by putting the tasks or the workload onto a queue, and then having n number of worker instances servicing that queue. Now this differs to a typical high-performance computing implementation, and MPI is one of these, where you'd have a boss node responsible for distributing work to worker nodes. And it's a very, very tightly coupled model. There's this through direct TCP connections. Extremely high performance, but very chatty, so low latency is key in this architecture. Whereas in Windows Azure, you should expect your latency to be much higher because of the way your virtual machines are inevitably distributed around a data center across upgrade domains. You should also expect your virtual machines to be more volatile because they have to be patched and upgraded when compared to a purpose-built high-performance computing data center. And so it's because of these characteristics that a queue-based architecture is often more appropriate. So I believe Microsoft are about to make an announcement about support for high-performance computing frameworks, so being able to control how your virtual machine instances are set up in a data center. So I'm not too sure where the announcement is. In fact, I'm not sure if I'm allowed to say that, but it's pretty vague anyway, so that's good. Sorry. So our first coding demo is a App Fabric service bus. So the App Fabric consists of the access control and the service bus. The access control doesn't excite me as much, so we won't talk about that. But the service bus is very cool. So we're going to see how we can use it to communicate in a publisher-subscriber type pattern. And I see that the service bus is a very powerful technology for communicating between disparate applications that are hosted anywhere. Particularly if they're hidden behind a firewall, then it's got some neat tricks for being able to tunnel into behind that firewall and set up communication, which I'm not going to show you today. But what I will show you is a sort of fairly simple demo of sending log or trace messages from an Azure service out to a client-side application. So we saw in the demo I showed you with deep exploration, those events that were coming through as each frame was rendered. And then when we looked inside the covers, those log messages were seen. They're all pushed out over the service bus, so really good for sending out application events or notifications. Cool. So let's have a look at the code. So the first thing we have to do to enable service bus communication is we have to set up a namespace in the service bus. Apologies, I'm using Firefox here. This is your fault, Nick. I can't seem to log out of that live account you logged in with, so never mind. So if we click on the App Fabric in the developer portal for Azure, select our project. And if we'll use one of the existing namespaces, I just want to quickly show you how easy it is to set up. So you set a unique namespace name within the service bus. You select the region that you want this to reside in, so Southeast Asia. And then these connection packs are quite key. So if you know you're going to need 100 connections, then you definitely want to prepay for them because they're cheaper than if you pay as you go. And what it doesn't point out here, which is very key, and I bumped into this the other day, is that there's actually hard quota limits on these connection packs. So if you select 0 connections, then there's a hard quota limit at 40 connections, and it'll just crash out. And if you've got 100 connections, then I think the quota limit is 150, so it's about 50% above what the connection pack is. So we're going to use an existing service bus namespace, GreenButton demo. Let me flick over to Visual Studio. So we're just going to create a basic Azure service project. Cloud Service 1 seems a good name as any. And we'll just add an ASP.NET web role. So hopefully you're all aware that you've got web roles and worker roles in Azure. Not much difference between the two apart from IIS and the web role. So add that in. The first thing we're going to do is just add a button to add a trace message. So we're just going to be using the standard system.diagnostics tracing architecture to do logging or diagnostics in our service. endpoint. Okay, so we go system dot. Cool, something original like hi TKid will do. Okay, so we've got that. Next thing we're going to do is we're going to add in an existing assembly, just because we're going to add a worker role later on, and we want to be able to share this implementation across both of those roles. Okay, so to create a service bus trace listener, or a trace listener that knows how to talk to the service bus, the first thing we need to do is implement this trace listener abstract class. So this is just your standard system.diagnostics implementation. And so this defines the write line, fail methods that you see in the tracing interface. Okay, and the next thing we need to do is we need to be able to configure up our namespace connection. So we've got the service, the path, the namespace name itself, and then the issuer secret. So if we go to the web config, we'll add those settings into here. Okay. So that's the namespace I'm using and the secret. Sorry. Okay, so with these namespace settings, we set up our URI and then we add the credentials into it. And then we create a channel factory that knows how to create channels of this type, iTrace channel. If you look at what that is. You can see this is just implementing the standard service model iClient contract. So the underlying architecture is the same sort of foundations as WCF, so the channels and the bindings and things, which is cool. And so then we have our own interface we've defined, which is the operations that we're going to be sending over the service bus. So we just happen to be mirroring the same operations that you have in the trace, but these could be anything. And the other key thing to note is we're using this net event relay binding. So this allows multiple server connections or publishers connecting or sending messages out to multiple client connections or subscribers. Cool. And then for each of the trace operations it'll be called, we're just going to make sure our channel is created. So if we don't have a channel, we'll create it from our factory. If it's not open, we'll open it. And then for each operation, we just call the equivalent operation on our channel. And if you can imagine, you've got 10, 100 or whatever instances out there in Azure, and you're getting all these messages. You need to be able to distinguish where they're from. So we append the current role instance ID to the message. Cool. So that's pretty much all there is to it, to communicating through the service bus. The next thing we have to do is we need to add this implementation to our collection of listeners in our config. So by default, when you create a web or worker role, you have this Windows Azure Diagnostics Trace Listener configured for you. So what we need to do is we need to add in our implementation. So let me just copy that in. Cool, so Service Bus Trace Listener, we're obviously going to need a reference to this class library. So you've got Windows popping up in the wrong place. Cool, alright, so we're good to go. Let's fire this up. And while waiting for that to start, we obviously need something on the client side to be able to receive these messages. So let's just flick over to this other project. And so on the client side, we've got the same configuration settings. And if we look at how the program is set up, it's just a console application. So we configure it in much the same way, except this time we create a service host to connect and receive those messages. And it's of this type, trace service, which is implementing our contract that we defined on the server side. So these write line, fail operations that we defined. And for each one, we just write it out to the console. So pretty straightforward. And then we set up just open the host and listen on that channel for any messages. So we'll start this up. how's our roll going? Okay, I've been on this monitor as well. Very handy. Cool. Okay, so we've got our Add Trace button. So if we click this, being a .NET web application, it'll no doubt take a while the first time. Cool, and so we see our message coming through in our console, and if we give it another click, we'll see it's quite speedy from then on. So this is sending the message from the Azure service that is hosted locally on this machine out to the App Fabric service bus in Azure, and then back to the console here. So it's pretty quick. Cool. So it all works. Right, let's just quickly flick back to the slide deck. This is quite a challenge with this monitor setup we've got here. So just to quickly recap, we had to configure a namespace in the developer portal, and so you have to specify your connection pack that you think suits what your requirements are. And actually another good point to raise in the connection pack is if you change it, say you decided you need 25 connections, and then the next day you're like, oh no, actually I need 100 or 500, you can't. You have to wait for 7 days. Don't know why that is, but it's very useful to be aware of that one. And then we created our service bus trace listener class to send the messages. So we inherited from the standard trace listener abstract class, and then we set up our client channel factory and our channel. And then we added our service bus trace listener to the collection of listeners in our config. Cool. So let's have a look at IntelliTrace. Has anyone here deployed an app to Windows Azure? Yep, cool. So if you did this, just recently IntelliTrace was made available for Windows Azure, but before this came along, you deploy a service, it'll all run up perfectly fine on your local machine, but then you deploy it out to Windows Azure, and you often have this problem where the role would go from initializing to busy to stopped, and then back to initializing, and it would just do this indefinitely. And it was really hard, it was impossible sometimes to know what was actually going on there. It was like, you throw this thing up to this big white fluffy thing and there's a cloud and nothing comes out, and you're like, what's going on? So what you'd do is you'd Google or Bing the problem and sort of work through the different possible causes one by one, and it was very frustrating and tedious. But now IntelliTrace is available for Windows Azure, so we'll see how we can use that to deploy any issues with our service. So this is going to give us very low-level exception information about anything going on with the deployment or even a running service as well. So what we'll do is, even though this is running up fine, perfectly fine on our local machine here, oops. One of the common gotchas is when you have a reference in your project, but it's not, the copy local isn't set to true. So when you get it out to Azure, it's missing a DLL that it needs, and it just doesn't work. So what we can do, so this service here encapsulates our Windows Azure service and holds all the roles and that we have for it, and all the configuration settings. And so we can deploy our service just from right within Visual Studio here. So we'll select our credentials that we've pre-configured with our client-side certificate. And this is going to go out through the management API and query Azure for the list of hosted services that we have. So we're going to deploy this to this particular hosted service. So these are pre-configured. And then we'll enable IntelliTrace for .NET 4. And we just need the events only. We don't need the full call information because we're not going to be debugging this. Okay. And we'll send that out. Just make sure this completes, and then we'll move on to the next demo. Cool. Okay, so that's started. We'll let it do its thing. Take a little while. Okay. Okay, so one of the cool features in Windows Azure is being able to mount a virtual hard drive in your role instance. And so if you have a legacy application that relies on file system interaction, it's going to allow you to easily get that up and working in Windows Azure a lot quicker otherwise. So it really sort of streamlines that migration path for you. So we use it for running external software packages in Windows Azure for different types of jobs. And so in some cases we package up an entire software application and all its dependencies into a virtual hard drive, and then we can just mount that in the instance and run it. So it's pretty cool. Because the other obvious way of doing this is to package up these files with their deployments and then send them up to Windows Azure, but you want to minimize the amount of stuff you send it up to Azure every time you deploy. So this is a better way. So you can mount a drive as writable, which means you have exclusive access to that drive, so only one instance can mount that at a time. Or you can take a snapshot of the blob where this virtual hard drive resides, and you can mount that as read-only, and any number of instances can mount that at a time. So that's what I'm going to show you today. And so to do this, we create a virtual hard drive in Windows. It's a standard virtual hard drive. Add our files into it and then upload it as a page blob. It's key that it's a page blob rather than a block blob. So let's have a look. Okay, so let's create a virtual hard drive. So in the computer manager, if you go on disk management, you can create a virtual hard drive here. Let's call this cloud drive. Cloud drive, yep. Cool, and I believe the minimum size is 16 megabytes, so that's all we need. The maximum is 1 terabyte. So we'll create that, initialize the disk with the master boot record. And then we'll create a new simple volume and just get as much as we can. And it has to be formatted with NTFS. Okay, and so I've created this naughty little text repeater application, which will just take some text and repeat it. Pretty cool. And we're going to copy that into our virtual hard drive. Pain in the bum. Okay, and so now we'll detach it. We won't delete it because we're back where we started. Okay, and now we're going to upload this to blob storage, into a live storage account. So I'm going to use this application called Cloud Storage Studio, but you could obviously write your own code to do this. It's good to know there's tool support for these things as well, though. So we will create a new container called VHDs, so a container to hold our blob. And then within this, we're going to upload a page blob. Grab our virtual hard drive. And we'll let that upload. Okay, so I mentioned at the start there's some subtle differences between how this works in live Azure and how it works in the development simulation. And actually the differences aren't that subtle at all. So in developments, you don't have to create a page blob or a virtual hard drive. You just simply create a folder to represent your virtual hard drive and make sure this is in the right place. So if you look in your user directory, users Dave or whatever your username is, app data local dev temp, and in here is where Azure puts its deployment. So if you run a service up locally, then it's going to create a folder in here. But this WAD directory you'll have to create, and this devstore1 account directory. And then from here on in, it treats any folders in here as containers. Okay, so this is a simulation that's running on the local instance. So we'll create a container for our folder for our container. And then in here, we create another folder to represent our virtual hard drive. So we'll give it the same name. Okay, so and then we can just chuck anything in this folder that we need in our virtual hard drive, which is quite handy because you don't have to muck around with virtual hard drives in your development environment. This can be a bit quicker. But one key thing to note is if you're running your service up locally, you can only connect from your development simulation. You can't mount a drive from live Azure. It's a bit of a limitation. Okay, so let's have a look at the code for this. Our deployment is still running off. Okay, so what we're going to do is we're going to replicate a common architectural pattern in Windows Azure, and that's where you have a user interface, a web application, and this is supporting users obviously, and it needs to do some back-end processing. So I don't know, maybe it needs to put an order request in for a customer. But it doesn't want to do that processing itself because it wants to stay responsive and lightweight and be able to support many users. So what it's going to do is it's going to put a message onto a queue, and then we're going to have a worker role sitting in the back end, which is going to be polling this queue looking for any work to do. Okay, so the web role just puts a message on the queue and forgets about it, and then a worker role is going to pick that up. What it's going to do, it's going to grab the text out of the message, and it's going to mount our virtual hard drive, and it's going to execute our text repeater application with the text. Okay, so it's a good sort of end-to-end solution here. So I'm not too sure who knows what about Azure in the room here, but it's a 300 level session. But if anyone has any questions, or what I'm doing isn't quite making sense, then please sing out, because we are touching on quite a few different areas here. So I'm going to add an existing worker role to our service. Cool. So this is quite tight inside Visual Studio here. It's pretty slick. Like, it's picked up the fact that we have a worker role that isn't part of our Azure service. So it's given me an option here to add the worker role project and solution. So we'll select that. And so now that's part of our Azure service. Okay. So the first thing we need to do is we need to create a message on the queue. Let's just get rid of this for a little bit. So we'll just put another button click event in. Cool. Let me just grab some code. Copy-paste utility stopped working this morning. Oh. Okay, so I'll talk you through this in a sec. So the first thing we need is a reference to our storage account. Okay, so we have a storage account created. We want to be able to create queues and add messages to the queues. So we need to add this connection string to our role properties so we know how to connect to it. So if we go to our web role and go to the properties, add in our connection string here in the settings tab. We're just going to use development storage at this stage. Okay, now that we've got our cloud storage account, we can create a cloud queue client which allows us to create queues, reference queues, get messages off them and that sort of thing. So we're just going to create a queue called queue, and actually we need to create this if it doesn't exist. Cool, so we've created a queue. Now we create a cloud queue message to put on that queue. And I've got some simple text in here, but this could be anything, could be binary content. And what we do is we put .NET objects in there. So we serialize a .NET object in there, which is a bit more useful for your application. And we add that to the queue. Okay, so that's our web role is happy, it's done its work, and can move on. So let's have a look at what's happening in the worker role. So we get a reference to the storage account again, so we'll add this to our properties quickly. Cool. Okay, and so the next thing we're going to do is we're going to mount this cloud drive. So let's have a look at the code to see how we mount this virtual hard drive onto our local instance. So the first thing we need is a local storage resource on our instance so we can cache this virtual hard drive or cache our view of it. So let's create that in our worker role as well. And we'll just 20 megabytes will be fine. We don't want to tick clean or roller cycle because if the instance gets restarted, then we want that cache to be maintained between restarts. And so with the cloud drive API, we initialize a cache with the path to it, where it resides on our local instance. And then we want to create our cloud blob client. So this is equivalent to the queue client, but for blobs. And we get a reference to the VHD's container we created. And then from that, we can get a reference to our virtual hard drive. And then with the URI for virtual hard drive, we can we can create a cloud drive. And at this point, we could call this mount code on the cloud drive we created, and this will give us a writable version of this cloud drive. But we only need read-only access, and we want any number of instances to be able to mount this at the same time. So what we do is we create a snapshot of this cloud drive, and we mount that down here. Okay. And in return, we get a drive letter back, a local drive letter on our instance that we can use. Cool. So then, let's put a breakpoint in there, I forget. So then what we want to do is we're going to prefix our text repeater.exe, so we have a full path to that executable that we can kick off. And then we get a reference to the same queue that we created on the client side. Okay, and this is another common pattern in a worker role. You loop indefinitely, poll in a queue for messages, and you never want to return from this while loop. Otherwise, Azure is just going to restart your role. So every time we get a message, we're going to kick off our processing, and then we'll sleep for 3 seconds. So all we're doing is we're building up the argument string with our text, and we're going to repeat the text 5 times. Cool. And so we're using a system.diagnostics process to run this external executable. And this happens to be a managed C# executable, but it could be anything. It could be C++, it could be Python, Java, anything. So it's quite useful to know that you can run really anything in Windows Azure, as long as you don't need admin rights. And so if you are kicking off a process in Azure, it's important to configure this process class correctly, otherwise it's just not going to work. Things like create no object and redirecting the standard error and standard output. Otherwise the process just hangs out there. So if you are doing this, make sure you grab either this code or you can find it on the web. And then we kick off our process and we check the exit code of 0, so everything is cool. And then we're just going to write out the output using our service bus trace, so we can see that coming out as well. Cool, so let's fire this up. Hope I haven't missed anything. Cool, so the web role has started. We've got a breakpoint in our worker role, so this obviously hasn't been hit yet. So here we go. Let's have a quick step through this just to get a closer look. So you can see our local resource here, as I mentioned before, the deployment is in this SRO directory. And this is the directory it's created for us to use as a local drive. And so we initialize a cache, we get a reference to our blob. There you go, DevStore account 1, VHDs. So this is going to be hitting that folder. And at this stage, as I said, we can mount this, but we want to create a snapshot, so we get a URI to that. And you'll see it just appends the date and time to the end of it. And every time you create a snapshot, it's 512 bytes of extra data it creates in storage, so pretty negligible, really. And then we get back our drive letter. So we're mounted to drive letter A. Gone is the floppy drive. And then we can prefix to our process, grab our queue, and then we're just going to poll for a message. We'll chuck a breakpoint in there just so we can check we're in that. Cool, so let's add a message. Cool, so it's been picked up straight away. We'll bring up this guy here. Okay, cool, so you can see that process has been kicked off and the message has been sent out over the service bus and we're receiving our client. So if we set another one without the breakpoints. Cool. So that's the Azure Drive working locally. Let's check on our trouble deployment and see how that's getting on. Jeebus, that's running very slowly. Okay, that's a shame. What we're going to do is we're going to deploy, even though that's not working, but we're going to deploy this current solution as it is out to live as well, just to check that we can use our live virtual hard drive as well, and just talk about some of the other things you need to be aware of. So the other limitation with the mounting a drive is that it doesn't support HTTPS. Okay, so you can only have an HTTP connection. So what you want to do is you want to maintain a separate connection just for your mounting your virtual hard drive, because you want all the rest of your communication with your storage accounts to be secure. Okay, so that's the best approach to work around that. So we'll add that in, and I think we're good to go. So we'll publish that. And because our production slot is busy, we'll just send this to our staging. So as I mentioned before, the other limitation of not being able to, if you're running a local Azure service, not being able to connect to live storage, mount a drive from live storage, is again, if you're about to deploy a service, a good practice is to change your connection strings to live, so you can check that everything's actually working with live storage, because there are subtle differences between live storage and development storage. But in this case, if you have your separate connection string for your Azure drive, you can leave that pointing to development, and then at the last minute, when you're ready, you can point it to live and deploy. So that works fairly well. Okay, so we'll let that carry on. Let's see if we can get our slideshow up again. Painful process. All right, there we go. Okay, quick recap. So we saw there's a difference between the live simulation, the live Azure environment, and the development simulation. In development, you need to ensure this directory exists, and then have a folder for your container, and then another folder for the actual virtual hard drive that you've created. And then to mount the cloud drive, you initialize your local cache, so you have to make sure you've created that local cache, and then you get a reference to your cloud drive. And if you only need read-only access, then you want to create a snapshot, and then you mount that to get the drive letter. And we talked about how we can only mount it in the same storage location, and no support for HTTPS. Cool. Right. So before we look at this code, I want to talk a bit about what the problem is. So when you read a message off a queue, a visibility timeout is set. If you don't specify it, it's going to default to 2 minutes. So that means if you haven't finished processing your message and deleted that message before the 2 minutes has expired, that message is going to reappear onto the queue, and another instance will pick it up and try and process it. Okay, so there's a great reliability feature. However, it has some limitations. What if you don't know how long you're going to take to process this message? So we have this problem where, for one type of job, a message could be processed in a second. On other times, it could be 10 hours. Okay, we don't want to set the visibility timeout any longer than it needs to be, and plus the maximum is 2 hours anyway. So, what do we do? The best thing, the ideal solution would be able to maintain a lease on this message. So we pull it off the queue, and then in the background we keep saying to the queue, yeah, we've still got it, until we're finished. But this feature doesn't exist. However, we can use the blob's lease feature to simulate this behavior. So the blob is a lease feature to support the Azure drive that we just looked at for writable drives. So when we create a message and put it on the queue, we're also going to create a 0-byte blob and associate it with the message. Okay, and so when we read the message off the queue, we also get our blob and we try to acquire the lease on it. If we can get the lease on this blob, then we know everything's cool and we can process it. If we can't get a lease on the blob, then we know someone else is working on it, and we just let everything go and we let the visibility timeout of the message expire, and it will just reappear on the queue again. So it's a very, very powerful concept, and it works very well. And I believe the storage team is working on a solution for a message lease, but they haven't given any indication on when it's going to be available. So let's have a look. Is the initial deployment even finished yet? Ah, interesting. Okay. Right, well, it says it's completed, but it hasn't failed as it should have, which is interesting. But I'll show you how we can access the IntelliTrace logs anyway. So, and the IntelliTrace logs are very useful. So if you've got a service running out there, not just for deployment issues, but your service is running out there quite happily, and then you see some obscure behaviour that you can't quite understand, then these will give you really good insight into some lower level exception information that isn't necessarily bubbled up to your exception management. So if we, in the Server Explorer in the Windows Azure Compute node, we can see all our deployments here. And we can, once we get this back, And from here we can download our IntelliTrace logs for that particular instance. So we'll kick that off, and the IntelliTrace logs is sent up to blob storage and then downloaded back to us. Okay. So let's have a look at this blob lease feature. So in our web role, when we create a message on the queue, we also want to create this blob and associate it with the message. So we'll just grab some code here. So in a real application, you'll need some way of associating this blob with your message. So presumably you'd have some unique ID associated with your message. You'd use that to name the blob. So in this case, we're just going to create an arbitrary blob. Oh, that was quick. Okay, we might as well look at this as soon as it's here. So you can see you get all this exception information, which, in fact, the storage client raises a lot of exceptions, which I'm not too sure why sometimes, but okay. So this is very detailed information. You can see the full stack trace of everything that's going on. So because it hasn't failed, we won't see our specific error message. So we create an arbitrary container to hold our blob, and then we create a blob called message1, and we don't care what's in it. We just need a blob, any old blob. Okay, and then we add our message as we did before. So on the worker role, we need to be able to check if we can get the lease on this blob message on this blob. And so what we'll do is, when we pick up a message, instead of just processing it, we're going to call this acquire and maintain lease code. So let's have a look at what this does. So we get a reference to our same blob. And at a high level, what we're doing is we're attempting to acquire the lease on the blob with a timeout of 30 seconds. It could be anything really. And then in the background, we're going to fire up a background thread to maintain this lease every 20 seconds. So every 20 seconds we call renew lease. And so we make sure this operation happens in a time frame that is shorter than our timeout that is specified. And then once our work is complete, we release the lease. So I don't know if anyone's used .NET 4. We'll see in the Parallels implementation, but this is part of the Parallels. So it's a task. It's basically the equivalent of a thread, but it's much more lightweight and the execution is more efficient. So we start that up, and if we fail to acquire the lease, then we're going to get this web exception, and we'll just return null to signify that someone else is processing the message. Okay, so what we'll do is we move our processing inside this code block here. Put that here. Let's put a breakpoint here and here. So at the moment we're just letting the default timeout visibility run, but we want to shorten that a bit just so we can see what's going on. And then the other thing we want to do is we want to simulate this process taking a little bit longer than it is at the moment. So let's pause here for 30 seconds. So this code is good, but at the moment we only have one processor instance, so it's not really going to achieve much. There's not going to be any contention on this queue message. So we want to configure up a second processor, our worker role instance, so we can have one reading the message and the other one trying to get it. So we'll add a second instance, and let's run this up. Oh, actually, it's going to fail, I think. Should fail. Oh, we haven't had our worker role yet. So this code here is going to fail, as I mentioned before, because we've still got our connection to live storage. We're going to get this error when we try and create the snapshot. So we need to point our configuration, our connection settings back to development storage. So roll back to 2. So it's a bit of a pain, that limitation, but I'll give our worker roles a moment to start. So one of them. Cool, so they're both happy. So we'll add our message and we're going to create our blob at the same time. And so if we look at what's going on here, the first processor, the first worker role hits this code. Ooh. Uh-huh. Okay, so I think I've got a blob sitting out there that's got an old lease expired. So you connect. Apologies, demo gods have been mean. So what's happened is I've got an old message here which has got the lease locked on it. So we'll delete that quickly. And we'll delete that quickly. And continue the execution. So we can just ignore these errors it's going to produce. Come on. Let's just restart that quickly. It'll work, I promise. Okay, that's deployed, which is cool. Okay, so we're starting up again. So gone into some undeterminable state. Are we running or are we stopped? It's neither. Okay, well, let me just talk over it because it's neither stopped nor started, which is a bit annoying. So what we would have seen here is the first, when we pull the first message off, or the message, the first worker role is going to get the lease on the blob message, and then it's going to carry on processing. When the second worker role comes in and tries to acquire this lease, it's going to get this conflict error, this web exception. And then so it's just going to let the message go, and the visibility timeout will expire again. So this works very well. One thing to be aware of, though, is when we go to delete our message, when you read a message off a queue, you get a pop receipt. And when you go to delete a message, you use that pop receipt to delete that message. But because this message has been read, and then it's gone back onto the queue again because the visibility is timed out, and then it's been read again, our pop receipt has changed. And so when we go to delete it, we get a message doesn't exist exception, even though we know it does. So the way you want to work around that, or one way you can work around it, is when you read a message, check to see whether that message has already been processed. Or there's potentially other ways around it. You could try and find that message on the queue again and delete it. But you still want to, either way, you want to make sure that all your messages are idempotent. So if you execute that same message a second or third or fourth time, the result is going to be the same. That's sort of the key thing. Oh, that's weird. Who knows what that's doing? So let's flick back to the slides quickly. Our deployments are taking a very long time, so I don't think that last one is complete. Let's just quickly check. That's the IntelliTrace download. Still initializing and busy. Okay, so we'll leave that for a bit. Cool, so a quick recap. We created a 0-byte blob and associated with a message somehow. So if you've got a unique ID for your message, you can use that. And then we acquire the lease when we get the message. We maintain this in the background thread. Okay, and then once we've finished completing our work, we can release the lease. And if that process falls over, then that lease is going to expire, and so another instance can get into there and get the message. So it works pretty cool. Come on, next slide. Cool, so just a quick summary of what we saw. We saw the service bus trace listener and how we can use that to send notifications out from our Azure service. So this is very powerful if you've got a deployed service and you want to get live information from it. It works extremely well. Or if you've got an application that's sitting behind a firewall, then as I mentioned, it's got some cool tricks for being able to tunnel into that. And that works by both of them setting up an endpoint on on the service bus, and then they share some information about what sort of communications they support, and then they use that to find some common ground, and then they can create a direct connection to each other. So that's very cool. Then we quickly saw IntelliTrace to have a look at the logs and see low-level exception information that the otherwise wouldn't be able to see. And then we saw the Azure Drive, mounting that from a virtual hard drive. Pretty cool. And then the message lease using the blobs lease feature. So the GreenButton we saw as well in deep exploration. So this is a custom-built plugin. However, we're developing this SDK, as I mentioned, and so if people want to get involved, or if you can see a way this could help the work you're doing, then come and see me at TechEd here, or send me an email at dave@greenbutton.net. And if anyone wants to see this actually working in live, once this deployment goes out, then just wait around afterwards. Or if you have any other questions, come and see me. Thank you.